Oh, hey guys, what's up? Eddie Alho here with KissAnalog.com. What do I have here? It's a power supply. Actually, this is like two stages of the power supply I'm going to design. Okay, one stage. Well, it's not the first stage. The first stage is going to be EMI filter. That's to keep all the dirty noise from out there getting into our power supply, and actually also to keep our noise from the power supply getting into there. Everything has one. We're going to be the same way, so we have nice clean power. Okay, so this power supply is going to be for an audio amplifier or for anything you want. You can convert it easily. Okay, but so the second stage after the EMI filter will be a PFC converter, power factor correction. It's actually active power factor correction because it's switching, it's doing stuff. There's passive power factor correction that you can do with inductors and that, and doesn't work, especially for our power levels, doesn't work as well as active power factor correction, which is really just a boost converter. And I've already done a bunch of videos on this, guys, so I'm just getting back into the swing, right? For those of you who've been around, you know what I'm talking about. I'm gonna have a playlist down below, and if you go through it, you'll see there's I'm holding this one too. This is the output stage, it's called the third stage. So this guy, PFC converter, it'll take the power from the AC, convert it to DC, and this guy's the DC to DC. And what he's going to do, not only offer DC to DC, but he has a transformer for isolation. So the ground on the input side is different from the ground on the output side. So it's just floating. It's totally isolated. For you guys that like expensive power cords and that, don't worry about it. Our power supply is going to take care of that. You never do have to worry about it, but switching power supplies takes care of all the stuff. Takes care of all your worries. Okay, what is it, Mansford? The guys at the audio group that does top-notch, real high-end stuff. That's all they do is switchers now. Mansford, right? Do I have that right? But anyway, I did a video talking about them one time. But all right, guys. So the PFC, that's the stage we've been working on. Now, this one has a dual. It's kind of like a dual PFC converter. There's two of them. So there's these power inductors. Okay, I've done a bunch of videos talking about power inductors and the PFC inductor and how you choose it and all this kind of stuff. So I kind of went into detail on that. I think I kind of forget where I left off. I was trying to hit each stage of this PFC so you could really understand each stage. Okay, so I'll put the playlist down below. I might rename it, so I started this as a JAT, John Audio Tech collaboration, and I think we'll still keep that name so that those who've been around for the ride will know that, and anybody that wants to build John Audio Tech's audio amplifiers, they can use this for that. Or if you've got different, you might have, who knows, there's a whole slew of different, I've got a bunch of more here, a bunch of different power amplifiers over here, and we're going to test a bunch of these. I got a few I got to build up. So this power supply, if you have a dual output, it's going to work great for that. If you only have a single output, fine. Put the two outputs together in parallel, okay? And it'll be great for that too. All right, so look at the playlist down below. And today, what I'm going to do is show you the schematic. And it's not complete, but it's pretty close. The bones are there, right? So anyway, yeah, so the bones are there. And we'll go through each part. I'll probably go through a design from start to end of the PFC converter and kind of go through it quick. I'll probably offer some hand notes and stuff to my YouTube members and my Patreons, so they can have those. Maybe put those in a book someday. Chapter of a book, PFC converter. I was going to write a book many years ago on power supplies, and now there's a bunch of them out, and I just never finished it. Anyway, so we can design them here on the channel, okay? All right, guys, so the PFC converter, what does it do? It's a boost converter. it takes, like I said, it takes the AC power, turns into DC power for the DC-DC converter with the isolation, okay? Now, this guy, you can all do things in one stage. It's complicated and all that kind of stuff. This is a brute force and pretty elegant way, I think, to do it. You have these stages that do their own thing, and they're not trying to do two things at one time. They're just doing the one thing. This is a boost converter. So it's universal input voltage, meaning 120 volts from the States, or those guys in Europe, you know, those guys, 220, 230 volts, whatever they have. Yeah. So what you do to make this thing work is you boost the voltage up higher than any AC RMS voltage that comes in. So the RMS voltage, you look at the peak of that voltage and you go, okay, it's 300 and some odd volts. So you go, okay, we're going to boost to 380, 400 volts. And that way it's always boosting, okay? So that's the idea. So it's just a boost converter. The only thing that makes it tricky is the input voltage isn't a continuous DC, like a DC-DC boost. It's taking pulsating DC, no longer AC. We go through a bridge rectifier and we get these pulses like this. So we slice that up in a bunch of chunks. It's almost like the opposite of a Class D audio amplifier, right? Instead of offering a whole bunch of slices and having an LC filter smooth it out, we're taking that and doing the other way. So what that does, though, is it's interesting how similar and dissimilar it is to a Class D. It's more similar than anything. The current we're pulling in from, the input, 120 or 230, whatever it is, the current looks sinusoidal because we LC filter that. So even though we're bringing it in and chopping it up, we're LC filtering it. So as far as what it sees is we're pulling in kind of you flip those on the input side, it's AC and it looks AC. So it's kind of interesting. It's kind of going the opposite direction of a Class D amp, but at the same time, it's kind of, it's like it's doing the same thing as Class D amp almost. I mean, so many similarities. Anyway, it's kind of cool, right? So so the input voltage of this is, these half sine waves, right? So it's a pulsating DC is what we call, right? So anyway, there you go. So that's what this guy does. So we have the bridge rectifier, and we have a small cap. So the bridge rectifier feeds a small cap. We don't have a big cap until after we build up our 380 volts or something, and then that's when we go into our big bulk capacitors over here. Now, that's the one disadvantage of, say, if we're designing power supplies just for the US, where we have 120, we'd only have to go up to the peak. So maybe we'd only have to go up to 200 volts or even less. And then we wouldn't need as high voltage caps. But it's no big deal. It's just, that's really the big hit is this. And then on this side, if we only went from 200 volts down to plus or minus, say, 45 volts, that'd be easier too, because we're stepping down less. So those Europe guys, they're making us drop 400 volts down. It's not a big deal, okay? We figured it out. Been doing it for a while, so no biggie. A lot better than the old days where you had to have a switch to do the cap doubler or whatever, what I'm talking about. So, all right, guys, so let's jump into it. The other thing, I've used lots of board layout tools, but and right now on the job, I use Altium, okay? So I've been using Altium for a long time for different jobs I've gone through, or Mentor. Those have been the two most popular tools probably that I've used. And I've used Cadence once, but now what we're going to do is use KiCad. It's KiCad, right? Not KiCad, KiCad, right? So we're going to use KiCad. Where's a KiCad? Somebody corrected me on that once. Let me know, guys. But we're going to use KiCad. And I updated mine last year because I was going to get back into this project. Got kind of pushed back again. So we're going to update the software again. I think they're version 8 now. So let's go do that, okay? And I'll show you the schematic real quick. Hope you guys are excited for the project. I'm kind of pumped up for it. So let's go.
All right, guys, so let's check this out. This is KiCad, and we want to see, there should be an update on this. This is what it looks like when you bring it up. You get the schematic editor, symbol editor, PCB, footprint, Gerber, all these things, okay? So let's go over and find out. Okay, let's come up here screen and see if we can find an update. Well, first of all, let's see what version I have. This is version 7.09. Wow, maybe I did update this already. This looks fairly updated. Here's the artist. What's this one? Translators, okay. This is the packagers. And this is a license. This is doc writers, lead development team. Okay, and 708. So we are at version 708 right now. Okay. All right, guys. So going back to about KiCad, I know they're up to a new version because it's been a while since I've updated this version. And right here, this says 709 release build. And when I go down here, I see the date, November 23. So yeah, it's been some months ago. So let's go to their website and see what we find. I think I do remember that you don't upload or update from this for some reason. Like you have to download the whole thing and start. So I think if I'm wrong, let me know, guys, because I'm going to learn KiCad, and hopefully people will learn along with me. All right, guys, so going to the website, I find this page, and here, if I go to the blog page, oh, that's where I am now, is at the blog. The home page looked like this, okay? So the home page does show that we are up to KiCad 804, okay, from July 17, 2024. So then I went up to the blog just to see what the history is. And if I go down here, I see version 8 was February 23rd, 2024. And look, 7011 was in just prior to that. I mean, just barely before that. So yeah, this is, and you know, they'll talk about the different things you get, but from what I understand, version 8 is another big, nice upgrade. So I'm going to start using it. We'll find out. I normally use Altium, and I use other programs in the past, but Altium is the one I use mostly now. But we're going to use KiCad, okay? So here, let's just go back to homepage, and here's documentation download, see what's new. I'll just pull this real quick up in case you guys are curious if you know this, if you want to see what's new. Okay, so sorting library tree columns. So not familiar enough with it yet to know how big of an update that was. Support hidden footprint libraries. All right, so here, let's go back to the home page, and let's just check out the home page, see what we see. We got schematic capture, PCB layout, 3D viewer. This is very nice. So, I mean, it just seems like a powerful program for being free. So let's hit the download. And I run Windows and Mac from my MacBook Pro, but I prefer running Mac OS stuff. I just think it runs so much better. So anyway, let's click on this guy. And then depending on where in the world that you want to download from, I think you can download from any of them. Looks like Clarkson University here. Okay. Oh, wow. You know what? Maybe I should buy one of these shirts. Yeah, their donations are a little bit higher than mine. All right, guys, this is still downloading. All right, so it looks like it came up. So just drag KiCad to applications. And I'm going to grab demos and drag it up there too. I'm not sure if I have to wait. Okay, I want to replace the old stuff with the new stuff. I'll probably speed through this so you don't have to watch this, but it looks like it's going to take less than a minute. Okay, I'm going to drag the demos up there too. And we'll replace the old ones, I guess. That was quick. All right, so this comes up and says, would you like to automatically check for updates on startup? So maybe that's new, because that's interesting that I didn't get that before. All right, so now let's go back to KiCad and go about KiCad. I know they're up to a new version because it's been a while since I've updated this version. And right here, this says 709 release build. And when I go down here, I see the date November 23. So yeah, it's been some months ago. So let's go to their website and see what we find. I think I do remember that you don't upload or update from this for some reason. Like you have to download the whole thing and start. So I think if I'm wrong, let me know, guys, because I'm going to learn KiCad, and hopefully people will learn along with me. All right, guys, I found the file, and when I tried to open it, it came up with this. So they've got this new library table, and so it's going to convert stuff to that. And it says this is recommended copy default global symbol library table. So I'm going to go ahead and do that. All right, so then we get this screen, and the file is created by an older version of KiCad. It will be converted to the new format when saved. Oh, okay. So I probably should save it right away. So just convert it. So I'll just come over here and I'm just going to say save. And that went away, and it's got the name right here, the PFC converter. So that's where we left off, guys. So I just want to show you that we're going to start here, okay? And I'm going to go through this design again. Just kind of quickly, I'm going to put a link to the old videos so that I'll put a playlist, okay, for this 400 watt PFC, okay? And we might make it more than 400 watts, but 400 watts sounds good. Let me know what you guys think. I think that'll cover most of the, or a lot of the power supplies that we might want to design. So yeah, that's what it looks like. Just kind of zoom in on it so you can see. I got to remember how to get my way around. So that's the input section, rectifier, capacitor, just a small capacitor. And here's our voltage regulator for our input to our control IC. And let's see, let's jump to this output. Sorry, okay, here's the output section right here. Here's our, well, this is the main diode, right? And this is the main switching. This is our bulk output capacitor. And then we just have this capacitor, just kind of helps this guy charge before this guy turns on, so he doesn't have to work so hard to charge him up from zero. So, and this is our main inductor. So those are the main components of this converter, these four parts right here, along with this control chip. And this is our feedback voltage. And here's our control chip with the sense, with the current sense resistor. that brings back the current sense into the control chip. We set up our frequency and our voltage comp, these three components here. So we have this nice so quiet ground right here that we'll make sure we lay out, and then we'll tie it into the power ground here at a particular point, like right there.
All right, guys. So, the thing that got me kicked off on this today, because I had another video I was going to do. So one of the viewers said, "Hey, when are we going to start that power supply design again?" And then also a friend who's a colleague, also was a colleague, we worked together. Now we work different companies, and I got a text out of nowhere, and he's actually working on one of these designs and wanted a few tips. And so I thought, man, yeah, that's a sign, right? And it's time for me to get back into this. So that's why this video jumped in today. So hope you like it. Guys, I want to give 2 thumbs up to my patrons, 2 thumbs up to my YouTube members, and Danny for being a team member. That's awesome. Guys, I hope you like these videos, and hope you're going to stay on board. Go look at that playlist, catch up on those videos, okay? Let me know on this flyback what I haven't covered in detail yet, okay? Because the next stuff I do on the flyback, I'm going to kind of go from start to finish. I'm going to kind of roll through it kind of quick, and I'll make the notes and stuff available to my YouTube members and my patrons, okay? So I got to give them something, because those guys are awesome. They hang in there with me, and the numbers have kind of dropped down. It's a tough time right now, right? Yeah, economy's not great. So being a YouTube guy these days, it doesn't pay like it used to. If it did, I'd be doing this full time. But there's guys who started full time with a lot less people than I have, and the money, yeah, they just don't pay like so use the affiliate links, because it does add up. It does help out. There's a bunch of stuff that I buy for the channel all the time, and it just adds up, and I kind of had to slow down. My wife's got to slow down on that stuff. So, and I've given away a lot of this. I get things given to me, and I give away a lot of it, but the shipping costs is really expensive. Costs more than the products in a lot of cases. So yeah, I'm going to start selling some of this stuff just to recoup. Anyway, maybe I can make a project out of this. The idea I had was just to make it available to anybody to go to. And I did do a lot of research on finding what board houses, and I didn't really settle on one yet. I think I have. And my idea was just to, like, you guys could just go there and just buy them, and hopefully I'd get some affiliate, credit for that. But that's the part that, may or may not work out, because, things have changed. People just don't, they've cut back on what they pay YouTube people. So, so right now this is still just an expensive hobby, but this is my, forte is power supply designs, EMI, all that kind of stuff. And so I've got a bunch of audio stuff. I love audio. So I've got a bunch of audio reviews, and I got some equipment people sent me. So I've been doing a bunch of those kind of reviews, just trying to dig myself out of the hole I got in. But yeah, I got to clean up this bench. So I got to sell some of this equipment so I can make the bench look nice and neat. I know some people are worried about the stuff falling over on me, but that's a big heavy duty bench behind me. And I got another big bench in front of me. So I think I'm safe, I hope. All right, guys. So yeah, so there's 3 ways to support the channel: liking the video, sharing it, that kind of stuff. That's awesome. These design videos get low numbers, so I try to do videos that get higher numbers because I figure more people like them. But this is something important to the channel, is to do design videos and show people how to do designs and how to use the test equipment in testing this kind of stuff. So, oh, and yeah, so that's why I'm doing some more solar stuff too, because audio amplifiers, solar, this, it's all analog. It's a lot, I mean, mostly analog, right? And they're all interrelated. One gives you some insight to the other one and vice versa. So I think it's great to keep that open mind and learn about other related fields. So, and it shows you also how to use the test equipment. And so, yeah, there we go, guys. Thanks for watching. We'll see you next time.